Hi everyone. So right now we are going to discuss a question which is based on binary search. So the question is aggressive cows. So let me read out the question. So it says that we have been given an array which is denoting the positions of stalls. And all the positions are distinct and there are k aggressive cows. And we have to assign those cows to the stall. Okay, let me show you guys. Now, suppose we have been given an array nums, and the array is basically denoting the position of these stalls like this, as it is shown here. And we also have k aggressive cows. And then we have to assign those cows to the stall, okay, such that the minimum distance between any two cow is maximized. Okay, it means we have to basically focus on the distance that suppose any two consecutive cow is there inside the stall, I mean inside a different stall. So the minimum distance between those two consecutive cows should be maximized. Okay. So first of all, we have to focus on the minimum distance. What could be the minimum distance, right? And if we are getting the minimum distances, we can find out the maximum among them, right? Now, one thing we can notice that whenever the question is like that, you find something minimum which can be maximized or find something maximum which can be minimized, there we can always go for binary search. So here also we're going to follow that approach. So first of all, I'll be taking this example and I'll be showing exactly what we have to do. So I've taken a diagram here. Now let's say what we have to do is, now suppose these are the position of the stalls which we have been given in the first example. That's on 1, 2, 4, 8 and 9. Okay. Now what we have to do is, like, suppose randomly I'm putting the cows on some stall like 1, 2 and 4. Then from here what we can get is difference between these two stalls. I mean the distance between these two stalls is 1 and between these two are 2. Okay. So what is the minimum distance I'm getting here? That is 1. Okay. Let me see some other combination as well. So here the cows I've put at stall 1, 4 and 8. So here the distance is 3. Here the distance is 4. So from this combination, I'm getting the minimum distance as 3. Okay. Now, this is another combination. From here, the first two cows, I can get the distance of 7. And from the last two cows, I can get the distance as 1. Okay. So here the minimum is coming out to be 1. And our target is to maximize these minimum distances. So maximize this minimum distance is 3. So this is going to be our answer. Okay. The first, let's see what we have to focus on in this question. Basically, we are not targeting the position of the stall, or you can say the stall number or the number of the cows. We are mainly focusing on the distance, right? So in binary search, the thing which we are targeting on, we have to play around that. So here the main target is distance. We have to first of all find the minimum distance, and maximizing is a later on thing. We will do it. But first of all, we have to check the distances. If I'll show you, let's say I have created here one more, let's say, position of stalls, and I'm assuming right now that the distance is 1 or 2, 3, whatever distance, 2, 3, 4, 5, something. Suppose initially I'm taking distance as 1, and my goal is to position the stall in such a way that the minimum distance should be equal to 1. At least the distance should be 1. So now we have to see, is it possible that we can place the cows in these stalls such that the minimum distance between them should be 1. Okay, let's check. um, Suppose the first cow I'm placing here. Okay, second cow, let's say I'll place here. Just keep on checking if the minimum distance is coming out to be 1 or not. So here this condition is holding true, minimum distance is 1. The third cow I'm going to place here. Okay, fine. Distance is 2, that is greater than equal to 1. So in this scenario also, it's possible we can place it in such a way. Okay, so distance 1 case has already been passed. Now let's check for distance 2. Hmm. Okay, so I'm checking for distance 2 right now. Distance 2 means now we'll check that okay, distance 1 is for sure we can place the cow in such a way कि उनका minimum distance 1 होगा. अब हमें क्योंकि distance को देखो maximize करना है, right? So now we'll be checking for the distance 2. We're just checking कि we can means we can stretch our capacity or not, right? So distance 2 के लिए क्या करेंगे हम लोग? Can we keep it at 2? Just check it. 2 minus 1 is coming out to be 1, which is not greater than equals to 2. So we'll try to keep it on 4. Okay, 4 minus 1 is equals to 3. That is greater than equal to 2. So we can keep it on 4. Fine. Now our next stall is at 8. Can we keep it on 8, the third cow, which is the remaining one? So yeah, 8 minus 4, that's equal to 4. That is greater than equals to 2. So congrats, we can have the means we can have the placement of cows with distance greater than equal to 2. So 2 is also a possible distance, which we can place our cows. Now suppose we change the distance to 3. Now our task is to check कि ऐसा क्या possible है कि if we are having the minimum distance between the cows as 3, can we place all the 3 cows? Okay. So let us check it once more for 3. So first cow I have placed at the initial position, right? For the second cow, let me check. Can I keep it on 2? No, we can't. Means it's not possible now. For 2 also we can't. We didn't put at 2. So can we put it at 4? 4 minus 1, that is equals to 3, which is greater than equal to 3. So yeah, it's possible combination. At 4 we can put it. Now, what can we do for the third cow? Can I put it at 8? Yeah, we can. 8 minus 4 is equals to 4, that is greater than equals to 3. So for distance 3 also, we can have a possible combination. It means minimum distance, if you are keeping it 3 as 3, that is also good to go. You can do that. But still, a question has told us that we need to maximize the distance as much as you can. Okay. So we have to check other distances also, right? So let me check distance 4. Is it possible to place the cows in such a way such that minimum distance between them is 4? Let me check this. The first cow is at 1. That's fine. We're not going to change it. The second cow, let me check if I'm keeping it at 4. Is it a possible combination? 4 minus 1 is equals to 3. Okay. Difference is, yeah, difference is not greater than equals to 4. So let me shift this cow and tell her to come to the another stall to 8. Okay. Now let us check key difference between 8 and 1 it's 7. It's greater than equal to 4. It's a good difference. So yeah, we can keep it here. Now, in order to place the third cow, let's see if it's coming at position 9 or not. No, if it's coming at 9 now, then we can see distance between 9 and 8 is just 1. But we are checking for distance 4, right? So minimum at least we should need at least at 12th position it should come to have the distance equals to 4. Okay, but that's not the case here. We have only limited number of stalls, right? So for distance 4, we can say that no, means we can't place the cows here, right? So we have figured it out that we tested it for distances 1, it passed. For 2 also it passed, and for 3 also it passed, but for 4 it didn't, right? And among them, the 3 was that distance which was maximum. Okay. I hope you guys are understanding what I'm trying to explain. Means all these distances which I kept here, no? 1, 2, 3, 4. This is basically something which I'm assuming, which people are assuming right now. We place the cows in such a way that this could be the minimum distance. And we are testing on these minimum distances, and at the end, we are comparing which is the maximum minimum distance. So basically, this is how we have maximized the minimum distance. Now, this is how we did sort of dry run. Let me write the code, and with the help of code, we're going to understand this now. Okay, so we have been given this array, and this is the k, that is the number of cows. Okay, so first of all, let me Just initialize the variables and all. Array dot size. And then, okay. So we are going to apply here binary search, okay? But the thing is, the stalls, if you see here, these are not sorted in ascending order. So first of all, we need to sort it. Since we have to apply binary search. Okay, sorry, it's array. Okay. Then I'm going to initialize my start and end. Okay. So one thing which I was clearly doing here everywhere, I was initializing my start as 1 and end is equals to nums of, sorry, array of n minus 1 minus nums of 0. Why I initialize my end like this? Because we are dealing with distances. We are not dealing with any index or number of stall or stall position. We're not dealing with that. We're dealing with distance. So that's why I've initialized start with 1, because minimum distance has to be 1, right? You can't overlap the cows. Okay. And the end is going to be the distance between this last position of the stall and the starting position of the stall, because that could be the range, possible range. Okay. Then I'm going to initialize my answer with 0. Sorry, it's array. Okay. Then I'll write the binary search code. So until and unless my start is less than equals to end, I'll be running this loop. So mid will be, now here what is going to be the mid? The mid which I'm declaring here now, this is this distance which we were updating every time. Which I told that we are assuming this to be the minimum distance. So that assumption here is going to be converted into mid. This mid is going to be basically guess that this could be the distance or not. Mid is equals to start plus end minus start by 2. Okay. And after that, what I'm going to do, we have assumed that okay, this could be the distance or not. But here we were checking manually, right? So here also we have to do some calculations, write some algorithm which is going to check it. Okay. So if let's say, let me take the name as is possible, that will basically check what we were doing here. We were checking the possibility, right? Whether it is possible or not to place the cows with that minimum distance. Okay. So if it is possible or not, I'll pass certain parameters there and then I'll fill it. Now, the thing is that if it was possible, what we were doing here, I just wrote it down at the end and I just told that okay, this is the maximum one. But here in binary search, what will we will be doing? If we understood that okay, distance 1 is possible initially, let's say we assume that okay, distance 1 is possible, then we have to store it inside our answer, right? We'll be storing it inside our answer, and then we'll also move towards the next distance. So we'll be doing s is equals to mid plus 1. And if it's not the case, if the distance is not possible, then what we'll be doing? End equals to mid minus 1. That the distance is too large, so you have to shrink yourself. So end equals to mid minus 1. And then at the end, I'll be returning the answer. Okay. So this is the binary search logic, and now the main thing which we have to write is this function. So here I'll be adding, okay, wait, spelling mistake. So here I'll be adding these parameters. For sure, these two will be there. And then one more thing I'll be adding here, that is our mid, because that's the main thing here. Okay. So if we just go back to the logic, what we were doing here, just imagine what we were doing. Initially, okay, yeah, I just destroyed it a little bit. Wait, let me just keep these things like this. So how we were comparing, सबसे पहले cow को हम लोग like by default we just like made it sit into the first stall, right? So हमारा by default क्या होगा कि let's say we are keeping its name as previous, okay? So previous जो हमारे स्टॉल का जो इंडेक्स है, फिर हमें हमारा जो प्रीवियस स्टॉल है उसको आप पोजीशन उसको दे दो नाम 0, बिकॉज बाय डिफॉल्ट दैट इज फिक्स्ड. And then, and since that is fixed, a cow is already sitting there. So I'm initializing the cow's count with 1, okay? And then after that, I'll be starting the loop from index 1. So I'll be doing it like for int I is equals to 1, I less than array dot size. Okay, wait, it's array dot size I plus plus. Okay, now I'll be traversing and I'll be checking if array of I minus previous, just try to reconnect it from this part. What we were doing, we were coming on an index and we were checking. Okay, now let's say before 4, I'm here on index 2. I'll be checking if 2 minus 1 is greater than equal to the required distance or not. If yes, only then we are going to place the cow, right? So here I was doing this. I was checking if array of I minus previous, if this is going to be greater than equals to the assumed distance, or here you can say it's mid. If that's the case, then you're going to place the cows. It means then you're going to increment the number of cows, and then you'll also update the previous value. बिकॉज अभी अगर हमने एक काव को यहाँ पे बिठा दिया है तो हमारे लिए हमारा जो प्रीवियस इंडेक्स है वो ये 4 है, ठीक है? नम्स ऑफ आई एंड एट द एंड व्हाट वी विल बी चेकिंग हियर कि ठीक है हमने काउज सारे के सारे प्लेस कर दिए या नहीं. अगर हमने सारे के सारे काउस को प्लेस कर दिया है इसका मतलब ये पॉसिबल है. ये जो डिस्टेंस हमने जो अज्यूम किया है दैट कुड बी अ पॉसिबल डिस्टेंस. तो हियर विल बी रिटर्निंग the cows which we have been counting in the entire algorithm, क्या सारे काउंट होकर के हमारे k से बड़े हो रहे हैं, मीन्स इट्स एक्सीडिंग k or not. Okay, let me try to run this code. Okay, why I'm writing nums everywhere, I don't know. Okay, sorry, I forgot to put the parameters here. So it will be array mid and then k. Anything else? Okay. Test case is passing. Let me submit this code. Okay, all the test cases passed. So this was all about this code. Now let me explain this once more what I did here, and let me try to reconnect it with the explanation which I told here. Okay. So in this explanation now, whenever I was telling about the distance which I'm assuming 1, 2, 3, 4 and so on, I was basically trying to see कि क्योंकि हमें निकालना था एक ऐसा मिनिमम डिस्टेंस जिसपे आप उन काउस को प्लेस कर सको एंड उस मिनिमम डिस्टेंस को हमें मैक्सिमाइज करना था, राइट? So the first thing which comes to our mind is to at least find those minimum distance between the cows, right? So this was something I was trying to do. Distance को हमने like ऐसे means check किया, like if the minimum distance is 1, 2, 3, 4 and so on. So 4 पे we found out कि 4 when the minimum distance we are keeping is 4, then it's not possible to place all the k cows in the given stalls. So we stopped at 3 and we realized that 3 was the maximum minimum distance. Okay. Talking about the code, what we did here, we sorted the stalls because it was not sorted and we have to apply the binary sort, so we sorted it. Then we initialized start as 1 and end as the distance between the end stall and the initial stall, because here we are dealing with the distance. Okay, this distance variable which you saw here, this is the main thing which we have to with which we are playing in this question. So for that we have initialized it in such a way. Then I initialized my answer with 0. Then wrote here the binary search code where I was updating the mid basically. So for updating the mid, that is here which we did, how we were deciding the distance. So the main logic was written in this function that if the arrangement is possible, if at that mid which you have calculated, if at that minimum distance you are able to place all those k cows, it means okay, very good, you keep that, you keep that count, you keep that minimum distance with yourself. But let me explore more. Okay, so that's why we did s is equal to mid plus 1, else n is equal to mid minus 1. It means if it's not possible, then okay, don't go further. Let me shrink down to less values, to less distance. Okay. And what here we were doing? Exactly this logic that we were trying to place. Suppose we got a minimum distance as 1. Now we'll be iterating the cows and we'll be checking. We'll be checking basically where we can place these cows so that the distance is coming out to be this minimum distance. So this was all about it. And talking about the space and time complexity. So since we are using your binary search, and along with that, we're also using a loop, which is traversing across the entire array. So the time complexity is big of n log n. And since we're not using any extra space as such, so space complexity is going to be big of 1. So this was all about it, guys. Thank you for watching. Bye bye.